Okay, so let us start with the first sum today, and at the end, if I think I will find time. The questions are very simple this week. At the end, then I will talk about the asymptotic Bode plot, the asymptotic Bode phase plot that I was telling you about in the previous session. Okay, so let us start. The first question I am going to give you. Okay. You can see my screen, right? Is the screen visible? Yeah. Okay, so this is the first sum. Very simple sum. You can just tell me. I will give you 3 minutes time, 3 or 4 minutes time I will give you. You can just tell me what you are getting. What?
A.
A. Okay. Anybody else? Anybody else? Who else is there? Navkirti is there, right? Navkirti, did you get the answer? What is your answer?
Sir, minus is the slope, so there will be poles contributing to that slope, and minus 20 into 360.
Minus 20 into 360. So
So there should be three poles.
there should be three poles. Why should there be three poles? Say I am saying there are I mean five poles and two zeros. Then what would be the slope of the Bode magnitude at omega tends to infinity?
So minus 60.
So now in this case, which I just gave you, there are five poles and two zeros. In that case, you do not see three poles. You see five poles, right? Hello, Navkirti. I was talking to you.
Yes, sir.
Yes. So see the logic must be very much clear. Why you are saying option A? See, each pole is going to contribute to minus 20 dB per decade, and each zero is going to contribute to plus 20 dB per decade. Okay. So at omega tends to infinity, what is the slope that you would get? That is minus of I mean the total number of poles minus total number of zeros into 20 dB per decade, because the effect of pole would be negated by the effect of a zero, right? So when you go to infinity, when omega tends to infinity, the entire thing you can imagine it like a clubbed thing. Zeros where the a club pole would be, so the number of club poles would be like p minus q. See, each pole is contributing to minus 20 per decade, and each zero is contributing to plus 20 per decade. Okay, so at omega tends to infinity, what is the total number of zeros or poles which is contributing to the slope? That would be q minus p, right? So in that fashion, you can say that P minus Q is equal to 3. You cannot say whether P or Q is 3. So from the options, now you have to check which of the option is going to satisfy this equation. Okay, so as in this case there is only one option which satisfies, the option is A. Okay, let us go to the next sum. There is another very simple sum. You can just yeah, so what is so pole 0 configuration is given to you, and you have been asked to find out which of the configuration is a configuration of phase lag controller or a lag compensator.
B.
What do, B you are saying? B for Bombay.
Yes. Yes. Yes.
It's a lag compensator.
A. A option, sir.
Maybe I have to see, because I have done this sums long ago. I have to see what option it is. Okay, so as I was telling, the in a lag compensator, the effect of pole, this pole would lie close to the origin, and the effect of pole will be more dominant as compared to this 0, right? Because 0 contributes to lead, not lag. So when you are talking about a phase lag compensator, there has to be a this what is the pole at closer to the j omega axis. Okay, so the correct option is A. These are very simple sums. Yeah, yes, tell me. Yes,
For lag compensator, the phase should be negative.
correct.
So tan inverse 0 minus tan inverse pole, it should be negative.
Tan inverse of pole minus tan inverse of angle contributed by the pole minus tan inverse of, I mean to say the angle contributed minus of angle contributed by the pole plus angle contributed by 0 should be negative.
Angle contributed by zeros minus angle contributed by poles should be negative.
Correct.
So poles should be more away. Okay, sir. Okay.
Understood what is the problem?
Yes.
There is a
Yes.
negative part of this. Okay. Next sum. Where was the next sum? Okay.
Sir,
Yes.
sir, how did you know zeros contribute to the lag?
0. If there is a 0, what is the angle contributed by 0? Say s plus 2. What is the angle contributed by 0?
Tan inverse omega by 2.
Tan inverse of omega by 2. There is plus tan inverse of omega by 2. Lead, not lag. Getting my point or not?
Mm. What you said in first, just by looking at the graph, how did you say that since?
Oh, just by
yes.
looking at the graph. See, when there is a, so this I mean, this is something that you should know. See, when there is a lag compensator, when I'm saying it is a lag compensator, that means what is it? The effect of pole should be, because pole is contributing to, I mean, the lagging of the system. The effect of pole must be dominant as compared to 0, right? When I'm saying it is a lag compensator. Getting my point?
Yes.
When a 0 is near the origin, then the effect of 0 is more predominant as compared to the pole. When a pole is closer to j omega axis, then the pole is more dominant as compared to 0. Why am I saying this? The pole is more dominant. When a pole is closer to origin, I am saying it is more dominant. Why am I saying this?
It governs the response.
Why?
Uh, the pole which is near
Tell
to
me mathematically. Tell me mathematically.
what did you ask, sir?
I'm saying कि uh, just now I told कि when there is a pole closer to origin, it is more dominant than other poles which are far away from the j omega axis. A pole which is closer to j omega axis is more dominant as compared to poles which are far away from the j omega axis. Now I'm asking, why am I saying this?
Yeah, the poles which is nearer to J omega axis, they
Are mo-
contribute they contribute more to the magnitude.
I'm not talking about magnitude at all. I'm talking why am I saying that poles are more dominant over here? Can you give me a response based on the time constant of the system?
Time constant is 1 by t. So
Yes. So
as t
Yeah,
increases, the value will become more near to 0 or maybe small.
see, take an example. Anubhav, take a very simple example. Okay. Say this pole is at -1, and this, say there is another pole over here. There is no, say, forget about 0. Say there is another pole over here, and this is at -2. Okay, so there is one pole at -1, another pole at -2. Okay, now tell me what would be the response of the system, the impulse response of the system. Simple system, k divided by s minus 2 into s minus k divided by s plus 1 into s plus 2. What would be the impulse response of the system?
yeah, k by s plus one into s plus two.
So find the time domain response. So it is some constant a e to the power minus t plus b e to the power minus 2t, right?
Yes, sir, exactly.
So what are the two time constant? One time constant is 1, another time constant is 1 by 2.
Yes, sir.
Because how do you get time constant? It is e to the power minus t divided by tau, where tau is the time constant. So
Yes, yes.
one is unity, other is half. So the one which has a lower time constant, that will decay down much faster as compared to the one which has a higher time constant, right?
Yes, sir.
That is why we say when there is a pole very close to origin, that pole is much more dominant than the other poles which are far away from the j omega axis. I'm repeatedly telling origin. Actually, what I mean to say is when a pole is close to j omega axis, it is far more dominant as compared to other poles which are far away from j omega axis. This is the,
The
yes,
dominant means what? It contributes more to the performance
dominant
of
means the one which is more what should I say? The one which is
the performance.
more responsible for contributing to something, more responsible for contributing to the response of the system.
So the one which decays faster contributes less.
Absolutely, absolutely, yes. Because at the end of the day you are looking at the steady state response, and also the transient response, but the one which is decaying down faster, you're not worried about it. The oscillations which are going to last longer, you're worried about that, right? If there are, say there are two poles, one is contributing some oscillations, and the other pole is also contributing to some oscillations which are decaying down. Both oscillations are decaying down. So these two poles are in the complex plane, not on the real axis. So if they are in the complex plane, say one is closer to j omega axis, other pole is far away from j omega axis. So the one which is far away from j omega axis, the decaying factor, the e to the power minus zeta omega n that you see, that decaying factor would be much faster as compared to the pole the oscillations which are responsible, which are caused by the pole which are closer to j omega axis. Are you getting my point?
Yes.
Okay. Okay, so then next sum, right? Okay. Okay, this is the next sum, and this is the last sum that has been allotted to me. You can just tell me what you are getting. Any answer yet?
Option is
Option A. Who is saying that? That is yeah, Sadat, right? Who is that?
Abhishek.
Abhishek. Okay. Okay.
So option A.
Okay. Anubhav?
Yes, sir, I'm doing right now. Yes, sir.
A. Okay. You are correct. A is the correct answer. So the root locus would look something like this. It starts from open loop zeros, and then it goes to the open loop. That what am I saying? It starts from open loop poles, and then it goes to the open loop zeros. So you see that this root locus would look something like this. So it starts from the right hand side of the S plane. So for the entire range of k for which the root locus is lying in the right hand side of the S plane, it is unstable. The moment k increases and it moves to the left hand side of the S plane, it becomes stable. So you see that it has already been told that k equal to 1.5 is the gain at which the root locus transits from right hand side to left hand side. So this value is k equal to 1.5. So those are all the sums that were allotted to me. Let me do some additional sums. Let us do that asymptotic Bode plot later, okay? Because I don't think we'll have much time now. Let me do an additional sum today, okay? Okay, this question I would expect you to do. I will give you 5 minutes time. I expect you to do the question. Yeah. So this is the question. So inputs, a CISO system has a dynamic equation which is given like this. And for the above system, you have to find the input with no initial conditions, okay? So you have to find the input which would produce the same output as the system produces when there is some initial condition which has been given over here. You understand the question, right? Have you understood the question? You have to find the input ut with zero initial condition that will produce the same output when there are no inputs but only initial conditions. This is what you have to find, and you have to find the input ut. Have you noted down the question?
No, sir.
Please, please I mean, note down these equations, the things that are necessary for you. I would try to find some pictures from net.
Noted, sir.
Okay. Anybody with the answer yet? Anybody with the answer? Abhishek, Navkirti, or Anubhav? Anyone?
No, sir, nothing.
So it is a lot of time. Have you found out the answer, or are you still trying? Anubhav, what is the status?
I'm trying, sir.
Navkirti, have you found out the solution?
No, sir. Solving.
How are you approaching it?
So, as so d square by dt, I put the first equation equal to 0 and then applied the initial conditions.
How are you
In,
applying the initial conditions?
so, by putting minus 4 in place of 2 dy by dt and 1 in 10. Y is given, so I'm putting it just 1 and then getting the value of
No, the
these.
things that are given is true for only 0 minus. Okay, these are dynamic equations. Y is not remaining constant. This is only at some instant it has been told to you. Initially, before I have started the system has these values. You cannot simply, replace dy dt with minus 4 and y with 1.
Okay, sir.
Anubhav,
Yes, sir.
are you trying to solve? How are you approaching?
Yeah. By converting into Laplace domain and putting the initial conditions, I obtained the transfer function.
Correct. Then
And Then the transfer function is equal to output by input,
Yes.
and yes, I got stuck at this step.
Then what? Then
Then I have solved till this step only.
okay, okay, okay. That is good enough. So this is one step, and
One by
the yes, yes. Tell
one by S.
1/s.
Yes.
That is Abhishek. Is that Abhishek?
Yes.
Abhishek, how can no? It is not 1/s, man.
Sir, one.
No. How are you getting 1/s? How are you getting all these terms?
Uh,
Sir, the transfer function is when initial conditions are zero, Laplace transform. So
Yes.
by
So
so how can we use these initial conditions
we are not
in
finding
DCT?
transfer function at all. We are just finding. We are just equating the response. We are not finding transfer function. We are finding y. We are finding the output. See, let me just show you the
sir, one
solution.
minute, sir, one
Yes,
minute.
1 minute. Okay. Transfer function is defined when initial conditions are zero, but we are not defining. We are not finding transfer function at all. We are finding the response y.
S by 3 upon 5 S minus 3.
So what is the input given time domain?
Okay.
You people are all from electrical engineering background, right?
Yes, sir.
Okay.
Yes, sir.
So you have also studied DC machine and all, right?
Yes, sir.
Okay. So I was trying to find a picture to show. I couldn't find much good picture. I will show you one picture and ask a very simple basic question. First, let us solve this. Then I will ask you.
I'm not getting answers.
Okay, the time I have given too much of a time. Let us solve it. Okay. Okay. So the first thing is when I am saying the input is zero. Okay. When the input is zero, that is u is equal to zero. So I am equating the entire thing is equal to zero. Okay. Now initial conditions has been given to me. Y dash has been given to me and y of 0 has been given to me as equal to 1. Now let us take Laplace transform of this equation. Okay, taking Laplace transform is not finding transfer function, Navkirti. You see u over here is 0. You understand? So you cannot find ys by us over here. Are you getting my point, Navkirti?
Yes, sir.
Okay. So now, what is the Laplace transform of d2y dt? 2. This has to be dt2. Just forgive this printing mistake. It has to be dt2. So d2y dt2. So if you the double derivative of yt would be what? The Laplace transform of double derivative of y. What is that? Navkirti? What is the
Sir, I
Laplace? Yeah.
forgot the formula.
How can you forget all these things? These are basic things. So S square of ys would be when there are no initial conditions. When there is initial condition given, that is minus of s into the initial value y of 0 minus y dash of 0. That is the this initial condition, that minus 4 which has been given to you. This initial y dash means derivative dy dt at t equal to 0 minus. At t equal to 0 plus or 0, I have just started the system. Say there was a switch and I have just switched it on. So that is why they say 0 minus. At t equal to 0, you switch it on. So 0 minus means just at the instant before you switch it on. These are the conditions that you have. So when you have this condition, so now what is the Laplace transform of this? This is again s of ys minus of y of 0 minus. That is the initial condition. Now you substitute this with the corresponding values which has been given to you in the question. Now simplifying this, you will get a ys. This is the expression for your output when there are no input, only initial conditions that has been mentioned to you in the question. This is the output you are getting. Now you have to find the input which produces the same output. Okay, so now the input is not equated to 0. What we are going to do is we are going to find ys from this equation. How to do that? Again, simple, as there are no initial conditions over here. So s square plus 2s plus 10 would be this, Laplace transform of this portion. So ys becomes 5s minus 3, that is the Laplace transform of this part. That is divided by s square plus 2s plus 10. Okay, so this is how you get y of s. So now you equate these two equations. Okay, you equate these two because you have been told you have to find an input which produces same output. So you equate these two. So if you equate these two, you end up getting this. So us becomes s minus 2 divided by 5s minus 3. And then you break it up like partial fractions and you get ut equal to this. Are you getting the solution? Did you understand the solution, Anubhav?
Yes. Yes. Sir. My approach is correct. I have made one calculation mistake. That's why I'm getting wrong answer.
Okay, okay, good, good. Now I will ask a very simple question on DC machine. Okay, very simple question. So you all have studied DC machine, DC motors. You first tell me how torque is generated in a DC motor.
Sorry, sir.
How is torque produced in a DC machine?
So interaction of filled, filled, filled MMF and armature MMF.
Okay, so is it because of the Lorentz law that you have studied? F equal to I into L into B sine theta. Where is the force being exerted? Is it being exerted on the conductors? Navkirti?
Sir, on the rotating part.
And not on the conductors.
No, sir.
Why are you saying not on the conductors?
So because they are on stator part and the stator is stationary.
No, I am saying, say, what does the Lorentz law say? What do you know about Lorentz law? This is class 12 physics. Navkirti, what
Force is
does
exerted on the coil,
force is exerted on a
rotating coil. If it's a permanent magnet DC generator, for example, then there is a coil that will be moving around due to the force which will be generated because of the current flowing in that force because of change of the.
so you are now changing your answer. You are saying force is not exerted on the rotor, it is exerted on the coil. Is it so?
Yes, a rotating coil.
Rotating coil, you are saying. Anubhav?
Yes, sir.
So where is the force exerted? Is it exerted on the coil or is it exerted on the rotor?
On the coil.
On the coil. Okay, Abhishek.
On the rotors.
On the rotor, not on the rotor coils.
Mm,
Abhishek.
Yes,
So you are saying it is not, the force is not being exerted on the rotor coils, it is exerted on the rotor.
yes.
Why are you saying, why are you saying so?
सर सपोज करते हैं कि एक मेरा डीसी जनरेटर है सर, तो डीसी जनरेटर तो इंड्यूस ईएमएफ होगा और वोल्ट की वजह से मेरा करंट फ्लो होगा
No, in
और
DC
करंट
generator you are rotating by a prime mover. You are rotating the
ये
rotor by the prime mover. I am talking about DC motor, say,
थ्रू कॉल्स.
through coil.
यस,
So, so you are saying coil because of the Lorentz law, right?
यस सर.
Lorentz force. What is the expression for Lorentz force?
सपोज सर कोई एक मैग्नेटिक फील्ड है सर, अगर उसमें कोई वायर करंट फ्लो करता है तो एक फोर्स इजेक्ट होता है, वो फोर्स को हम
What
लोग
is the
वायर
expression for the Lorentz force?
बी आई एल.
I into L cross B.
Yes, sir. I into L. B I L. Flux density into current into rate
L
on
vector
A.
cross B vector. It's a vector product. Anubhav,
Yes, sir.
do you agree with the point that Abhishek is saying that force is equal to I into L cross B, and because of this force, Lorentz force, the force is being exerted on the conductors, and so the DC motor is moving.
Sir, Lorentz equation.
Lorentz force equation. What is the Lorentz force equation?
Sir, F is equal to QE plus QB cross B.
That is the force exerted on a charge.
Yes, sir.
I'm talking about the Lorentz force.
BIL sin theta.
I into L
Ah,
cross
yeah,
B.
yeah. In magnetostatic, the a current carrying conductor produces
Yes.
a magnetic field. So, uh,
I into L
yes,
cross
yes,
B, right?
yes. Correct.
So the wire must be placed in a magnetic field, and then only the force will be exerted, right?
Yes, yes,
You agree to my point, right?
yes, yes.
Okay. Now, Kirti, do you agree?
Yes, sir.
Okay. Now tell me, where am I going wrong? If whatever you have said is right, where did the picture go now? Oh. Look at this picture, okay? Look at this picture. This is not a DC machine, but still the flux line should be like look like this only, right? So you see in the air gap, in the slot where the wire is present, the coil is present right over here. You are placing the coil over here in the rotor, right? So what is the magnetic field inside this in this air gap? Are there any flux lines in this region? In this slot where the conductor is placed, are there any magnetic field lines?
No, sir.
No, sir.
So how is the force being exerted? Because you said F equal to I into L cross B, and I can see clearly from this picture that magnetic flux is flowing through the core, and there is no field in the air gap at all. In this air gap um, uh, in which these coils are being placed. In this region, there are no flux lines at all. So where from the force is being exerted?
The Fleming's right hand rule.
Fleming's right hand rule gives you the direction of the current when there is a motion in the conductor.
Yes, a field current and then motion of thumb.
Does not say about the force that is being exerted. I am saying uh, the reason that you gave, कि Lorentz law is responsible for the torque production. I am saying the force is the wire must be placed in a magnetic field for it to experience a force. But in this case, I am seeing that there is no magnetic field inside that place at all. There is very less magnetic field. So if this is responsible at all for the production of the torque, then what is the need of for all this core? We can just wind this in a thread and then just put it on the rotor.
This core gives the flux path, a low reluctance flux path to the
Yes, the
flux.
core is giving the low reluctance flux path. That is why most of the magnetic field is restricted to the core itself. But there is no flux lines in the slot in which the conductors which are carrying current are placed. That means there is no magnetic field on the conductor in which is carrying current. If there is no magnetic field or there is very small, very low magnetic field, then the torque produced must be very less.
Yes, sir.
Then how are we saying that the Lorentz force is responsible for the production of the torque?
सर फोर्स जो है हाई कंसंट्रेटेड फील्ड से लो कंसंट्रेटेड फील्ड की तरफ भी तो फोर्स लगता
क्या? I didn't get you.
है हाई कंसंट्रेटेड मैग्नेटिक फील्ड से लो कंसंट्रेटेड फील्ड की तरफ से
What are you trying to say?
जैसे सर सपोज करते हैं कि सर ये आर्मेचर की
The
वजह से जो
flux path is
करंट
complete. You are talking about the reluctance and all this. The flux path over here is complete. Just tell me why is it happening? Why is it whatever we are saying, is it correct or there is something mistake? There is some mistake in our thinking. That is what I am asking. And I'm not going to give you the answer today. You have to, what you will do, I'm giving you an assignment. Do this assignment, okay? Draw some pole and below that uh, place some slots, place some conductors in it, and one picture, in one picture what you do is you say that there are no conductors, that the conductors are not carrying any current. Draw the flux lines. In the second picture, what you do is you draw the flux lines for the conductor only, saying there are no poles. I mean, forget about the pole and just show the flux lines because of the conductor carrying current. And then in the third picture, you draw the resultant of the flux lines. Okay, this is the assignment I'm giving you. And in the next coming week, you show me this picture. It will hardly take you 10 to 15 minutes to draw all this.
सर मैंने ये बनाया हुआ है सर आज ही बनाया है सर जो कि
और-
ये जो नोट सपोज करते से तो दो पोल का मेरा मशीन है सर तो जो नोट पोल के जो अपर साइड में वो हाई कंसंट्रेटेड फ्लक्स लाइन होगा जो कि आर्मेचर से होते हुए साउथ में लोअर साइड में ज्यादा कंसंट्रेटेड फील्ड होएगा मीन्स जैसे दो पोल का मशीन है से एक रोटर है तो एक मेरा आर्मेचर करंट की वजह से एक मेरा फ्लक्स लाइन बनेगा सर और एक मेरा पोल की वजह से फ्लक्स लाइन होगा और दोनों एक आपस में मिलेगा तो जो नॉर्थ साइड जो ये नॉर्थ साइड की जो पोल है सर जो अपर केस में हायर कंसंट्रेटेड रहेगा और उसके बिलो में सर नॉर्थ साइड में लो कंसंट्रेटेड फ्लक्स डेंसिटी रहेगा सर और साउथ साइड में अपर साइड में सॉरी लोअर साइड में ज्यादा फ्लक्स डेंसिटी रहेगा सर और अपर साइड में कम रहेगा सर जिसकी वजह से एक मेरा सपोज जेट टाइप का एक फोर्स लगता है सर जिसकी वजह से वहां से तो रोटर स्टार्ट हो जाता है सर
No, just forget about what concentration you are saying. I am not understanding what concentration you are saying. If you have any picture, can you just post that in the chat window?
ये सर मैंने पिक्चर बनाया है सर बट मैं शेयर कैसे करूं
Is it possible for you to upload pictures in the chat window or no?
नो सर
It's difficult. Okay.
one option has a screen sharing cameras.
Okay, that you can do. You can. I am unsharing. Yeah, you share your screen. That you can do. Share your screen.
Okay.
No, no, I'm not talking about this at all. I forget about the there are no slots over here. So this is what you are showing is the effect of armature reaction. Okay,
Yes.
this is the effect of armature. I'm not talking about that at all. What I am saying is you just draw one pole, and below that pole you draw three slots. Are you getting what I'm saying?
No. Sir.
Wait, let me show you then what I am trying to say. Okay, there is. Okay. Okay. Okay, you see this picture. Can you see this picture?
Yes.
You see there is only one pole and below that there are slots. And in these slots there will be conductors placed like just like this. You see these slots and there are conductors placed on it. Draw a picture like this. Draw a picture that this entire thing is the north pole. This entire thing is a pole. So north or south, whatever you like, you just place it. You draw the flux lines produced by this north pole alone. In the second picture, you place conductors in these slots, either dot or cross, whatever you feel. You take the direction of the motion and figure out accordingly what would be the direction of the current. And because of that conductors, you draw the flux lines of only these conductors. Flux lines produced only by the armature current, which is placed in these slots. And in third picture, you show me the resultant flux that is being produced. Okay, this is an assignment. I want you to show it to me in the next class. Can you do that?
Yes, sir.
Okay. Navkirti, another question for you. You see this transformer, you see?
Yes, sir.
So can you tell me whether the voltage equation, so say this is a coil, these are three coils placed on these limbs. So is the voltage equation, that is V, say this is the voltage, V1 is the voltage across this conductor, V2 is the voltage across this coil, and V3 is the voltage across this coil. So can we say V1 by V2 is equal to N1 by N2, where N1 is the number of turns of this coil and N2 is the number of turns of this coil? Is it possible to say?
Sir, there are turns of the other coil as well.
So is the voltage equation valid?
Yes, sir.
It is valid. Try to prove it in the next class, okay? Try to prove this thing in the next class.
Okay, sir.
That will not be valid. That is why I asked the question. Anyways, let us end the session for today. We will meet again on Friday. Okay, I have an exam on 19. Maybe I will keep the session short on that week. Okay, I will be taking 15 minutes or 30-minute class, and then I have to study because I have my exam coming. Okay, so thank you. Enjoy your weekend. We will meet again on the next Friday.
Thank you,
Thank
sir.
you, sir.
Thank you.